Hello everyone and welcome back to our YouTube channel Code Logic. So in this series we are seeing the faang interview questions. So in our previous videos we have seen some of the questions like finding the middle element and the detecting the loop in the linked list. Okay, so this is the sixth problem of that series. So in this video we are going to see intersection points of two linked lists. So yeah, if you are new here then please subscribe to our YouTube channel, and without wasting any time, let's get started. So you can see here we have given one linked list. Okay, so head of two singly linked list, head 1 and head 2. Then we have to return the node at which two linked lists are intersecting. Okay, so if two linked lists have no intersection point, then we have to return the null. Okay, so in example you can see here, so we have two linked list A and linked list B. So A1 A2, B1 B2 and B3, and then both the linked lists are intersecting at point C1. Okay, so we have to return the C1 as an output. So time complexity for this problem is O of n. We have to solve it in O of n into O of n. Okay, and then auxiliary space complexity is O of 1 time. Okay, so we are not allowed to use any extra space. So there are different approaches to solve these problems. So this is our first approach, in which we have to use the nested loop. Okay, so two nested loops. One is loop, outer loop is for the first list, and then inner loop is for the second list. And then we have to check in inner loop if both the nodes are same or not. So check if any of the node of second list is same as current node of first linked list. Okay, so if both the nodes are same, then we can say that node is our intersecting point. Okay, so the time complexity is m into n, where m is the length of first linked list and n is the length of second linked list. Okay, so time complexity is not acceptable here, because we are using two loops, and then it's taking too much time. Okay, so we are going with a different approach. So this is our second approach. You can see we have here a linked list 1, okay, and linked list 2. So first what we are going to do is we'll first count the number of elements which are present in a linked list 1. So that will be C1. Okay, then we are going to count the number of elements which are present in second linked list. So that will be C2. Then we'll take the difference. Okay, so absolute difference, which is D. Now we are going to traverse the bigger list. Okay, whichever list is bigger, we are going to traverse that first with the first node to D nodes. Okay, so we are moving D nodes ahead in a bigger linked list. Okay, so and after that we are traversing both the linked list parallelly till we'll came across a point common node. Okay, so this is a better approach, what we can say, and we are going to implement this approach only. So first we'll dry run, and I'll explain you how this approach will work, and then we'll start the coding part. So you can see we have two linked list 1 and linked list 2. First we are going to calculate the length, okay, of linked list 1. So linked list 1's length is, you can see 5 elements are there. Okay, and then length of linked list 2, so that is 3 and 3, 6 elements are there. So we'll take the absolute difference. Okay, so difference is 1. Okay, and a linked list 2 is bigger than linked list 1. Okay, so starting points are this one, head 1, and you can see here head 2. So we are going to move number of nodes ahead of in a bigger linked list. Okay, so you can see bigger linked list is linked list 2. So we are moving this head node. Okay, so we are moving this head node one digit ahead, one node ahead. So this is our head 2. So now this difference is 0. Okay, so we are now we can move both the nodes simultaneously. Okay, so first we'll move this node, and then we'll move this one. So here you can see this is our head 1 and this will become our head 2. And again I will check if both the nodes are same or not. So both the nodes are not same here. Okay, so then we'll move again ahead by one digit, one node. So now head 2 is pointing here, head 2, and also head 1 is pointing here, head 1 is pointing here. So here you can see both the nodes are pointing to the same element, that is C1. So now we are going to return this C1 element. Okay, so we'll return this C1. Okay, so that's it for the dry run part. Now we'll start with the actual coding part. So here you can see we have created one linked list using array. Okay, and we have created another linked list using array. So here we have joined those two linked lists. Okay, so after joining the linked list will look like this. Okay, so first linked list will contain 10 for 20 30 40, and this 50 60 50 35 and 65, and then second linked list will contain the 15 and 30 elements. Okay, so we have joined it here. Okay, at 50, so we have to return this 50 element. Okay, so now we have written one method here, find intersection point. We have passed to linked list, and we have stored that result in a result variable which is of type node star, and then we have printed that result data in our console. Okay, so we are now going to write this method. Okay, so as we have discussed, first we'll check if head 1 is exactly equals to null. Okay, so if head 1 is null, then we'll return the null element from here. Then we'll check if head 2 is exactly equals to null, then we'll return the null element from here. If both the linked lists are not empty, then we'll calculate its length. Okay, so length L1 equals to, so we have written one method here, find length. So in our previous videos also I have explained you how to calculate the length of linked list. So I'll try to provide that link in the description box, also in the I button. Please watch it if you have not watched that video. So now we'll calculate the length. Okay, so find length, and we'll pass the head node here, so head 1. Then we'll calculate the length 2 using same method. We'll pass the head 2. Now we'll check which one is bigger. So if L1 is greater than L2, otherwise. Okay, so if L1 is greater than L2, we'll first calculate here difference. So int difference equals to absolute difference between L1 minus L2. Okay, so if L1 is greater than L2, then we are moving the head 1 with the number of differences. Okay, so while difference minus minus will move our head 1 equals to head 1 arrow next. Okay, in other case, if linked list 2 is greater, length of linked list 2 is greater than linked list 1, then we'll move our head 2 node. Okay, head 2 equals to head 2 arrow next. Now both the nodes will move simultaneously. Okay, so for that we'll use while loop, while head 1 and head 2. So if head 1 is present and head 2 is present, then we'll go inside this while loop, and inside which we are going to check if head 1 is exactly equals to head 2 arrow data. Here head 1 arrow data. If this is the case, then we'll return any one of the node, head 1 or head 2. So we'll return head 1 from here. Otherwise, we'll move head 1 equals to head 1 arrow next, and head 2 equals to head 2 arrow next. Okay, and if we have reached any end of any one of the linked list, okay, then we'll came out of this while loop, and in that case we are going to return the null element from here. Okay, so if it's a null, that means either any one of the linked list is empty, or both the linked lists are not intersecting each other. Okay, so we'll execute the code now. So you can see intersection point is 50. So as we have seen here, okay, in our diagram, so that is a 50. So yeah, that's it for the video, guys. If you like the video, please like, share and subscribe. Thanks for watching the video. See you in the next video. Till then, bye bye.